Good morning. Can you hear me?
Yes, ma'am. Yes.
Hi. So before I start with the analysis of beams, if ever may tanong ako, kindly uh, put your answers dun sa my chat box. You don't have to open your microphones. Dun na lang kayo sa chat box mag-send ng mga sagot nyo if ever adamanti damaga. Okay, are we clear on that? Para ma-screenshot ko na rin yung mga nagbibigay ng sagot. Okay, so let's start with the lesson 2 for chapter 2, which is the analysis of beams and frames. Bakit ko pinagsama si beam at saka si frame? Now, in the analysis of frames kasi, pareho lang siya sa may analysis ng beams. So let's start with the analysis of beams. Now, we have prismatic beams. Pag sinabi kasi natin prismatic beams, the entire length of the beam is made of the same material. So, pareho sila ng mga properties. Hindi man pareho yung kanilang mga areas, but in terms of moment of inertia and other properties, they are the same. So, yun ang tinatawag nating prismatic beams. Now, there are terms we are going to encounter in the analysis. We have this shear. This was discussed already during your lower years. Bearing moment, internal axial force, and the elastic curve. Now, itong elastic curve na to, this is a diagram wherein pinapakita doon yung possible na deflection ng inyong beam. For example, as you can see there in your screen for a certain beam, yung broken lines na nakikita nyo, that is the depicted deflection of that beam when you're going to apply a distributed load. So let's go directly to the analysis of beams. So for this beam, you're required to determine the external reactions of the beam shown. And so dito sa may, since we are in determinate structures, tatlong equations lang yung usually na ginagamit natin. The equilibrium equations, we have summation of forces along the x-axis, summation of forces along the y, and the summation of moments. So for this example number 1, you're required to determine the external reactions. When we say external reactions, this pertains to the support reactions. So for in this case, for this beam, the reaction at A, C, and E is required. So, very first thing you have to do, since may internal hinge doon at point B, and let's say, pag inalis ko yung hinge na yon, magiging indeterminate itong beam na to. But since there is the inclusion of the internal hinge, nagiging determinate itong beam. So, for beams with internal hinges or internal pins, first thing you have to do is to, kumbaga, paghihiwalayin natin itong beam na to, maghihiwalay siya doon sa may hinge. So, nasa sa inyo na if we're going to analyze first the left or the right side. So, in my case, I'm going to analyze the left side of this beam, yun yung A to B. So, since pinaghiwalay ko na siya, at that point B, where kung nasaan yung hinge, meron tayong internal reaction, yung si BV. Meron tayong BV, BH, at saka yung moment. Inalis ko na si BH kasi wala namang forces along the x-axis. Inalis ko na rin si moment kasi, well, if you're going to check, magsi-zero rin si moment. Kaya si BV lang ang may value. Now, if I'm going to take summation of moments along B, wherein clockwise is positive, can you double check that one? That should be, this should be clockwise. Since si RA, pag nag-moment kay B, counterclockwise, so that is negative. The moment arm or yung distance ni A hanggang kay B is 5, then this is a uniformly distributed load. Since this is a uniformly distributed load, I have to take the area of this uniformly distributed load, that is equal to 30 times 5. Then the moment arm, pag nakuha nyo na yung area nito, the resultant of this is located at the center, which is half of the length, which is 2.5. So my RA here is 75 kilonewtons downwards. If I take summation of forces along the y-axis, makukuha ko ngayon yung value ni BV. Now, if you want to double check, if pwede rin namang gawin nyo yung summation of forces along the x-axis, makikita nyo doon that BH is equal to 0. If you take, if you include a moment dito sa, let's say, moment B, di ba sabi ko kanina kasi inalis ko na to kasi magzi-zero out din naman. If you want, you may want to double check it, makikita nyo doon 0C and B. So pag nakuha ko na ngayon yung value ng internal reaction na si BV, I can now go to the other side of my beam, which is the beam BCDE. So, kanina yung BV is upwards yung direction. Kapag lumipat na ako sa isang side ng beam, you have to take note, dapat nasa equilibrium pa rin tayo. The same magnitude, but different direction. So, for this beam, nakuha na natin yung internal reaction at point B, which is BV, that is equal to 75 kilonewtons. I can now solve for the value of my RC and RE. So, summation of moments at C, I can get the value of my RE, which is equal to 70 kilonewtons. Kindly double check the values I am presenting to you, kung tama ba yung mga pinaglalagay ko na values dyan. So, RE, kapag nag-moment si RE kay point B, that is counterclockwise, kaya negative. Now, itong uniformly distributed load na to, I have to take the area of that is equal to 30 times 4. The moment arm of this 30 kilonewton per meter is half of 4 meters, that is 2. Then, itong 75 na to, pag nag-moment kay point E, that is counterclockwise, so negative. And this 60, counterclockwise din pag nag-moment kay point E. So, my R is equal to 70 kilonewtons upwards. Next, summation of forces along the y-axis. The value now of my RC is equal to 75 kilonewtons upwards. Okay. So, nasolve ko na yung mga reactions. Yung mga reactions for this beam. This is now my final answer for the external reactions. Now, kapag titingnan ninyo doon sa may, I just want to go back doon sa may notes ninyo. Dito sa notes ninyo, especially dito sa may page 4, and if you happen to open your notes here, may part dito na diniscuss regarding the steps on how to draw the shear and moment diagram. Now, we have to draw the shear and moment diagram para mas madali sa atin na makita yung mga maximum and minimum values for shear and bending moments. Now, dito sa page 4 kasi diniscuss dito how to determine the values for your moment and your shear diagrams. So, dito sa may notes, pinakita dito yung mga how to formulate equations. How to formulate equations dito sa may page 5. Let's say I want to get the moment at this point wherein nag-cut siya at distance x. This is the equation wherein x is equal to 800 meters. So, maraming equation yung diniscuss dito on how to get the values for the moments for this beam. Now, kung special mahirap kasi sayang yung oras kapag mag-equate ka pa or gagawa ka pa ng mga equations mo just to draw the moment diagram. I just want to show you yung diretso tayo na, shortcut na niya. No, malesen ti oras tayo magsusolve. Now, there is a simpler way to draw your shear and moment diagram. All we have to do or to know is the relationship between load and shear moment. So, anong sabi dito for the relationship between load and shear moment? First, the slope of shear diagram at a point is equal to the intensity of the distributed load. Second, the change in shear between points A and B is equal to the area under the distributed load diagram between points A and B. So, ano bang ibig sabihin ng mga relationship na to? Again, I just want to show you the relationship between load diagram, shear and moment diagram para mas madali na i-drawing natin yung ating mga shear and moment diagrams. You may want to follow itong gaya ng sabi ko, itong ginawa ng libro in formulating the equations to determine the values of your moments and your shear. Pwedeng gamitin nyo to pero mas maraming oras ang makukuha nyo dito. I just want to show you the relationship between the load, shear, and moment para mas madali nating mai-drawing yung ating mga shear and moment diagram. So going back to this beam, if I'm going to draw the shear and moment diagram of this beam, madadalian na lang ako. Wait. Ay, shucks, nasa last. Sorry, nasa last pala ako. Let's have another example para makita natin kung paano gamitin yung relationship between the load, shear, and moment diagram. Now, for this beam, simply supported beam, uniformly distributed load, yung 40 kilonewton from B to C. So, this is uniformly distributed load. So, very first thing we have to do is to determine the external reactions at point P and point E. So, if I'm going to take summation of moments at point E, again, clockwise positive, can we correct this one? This should be clockwise. So, 60. Itong 60 na to, kapag nag-moment kay point E, that is counterclockwise, RB will have a clockwise moment. And itong uniformly distributed load na ito, kapag nag-moment kay point E, that is counterclockwise, kaya negative. Now, itong nasa loob ng bracket, that is the uniformly distributed load. The area of that uniformly distributed load is this one, 40 times 3. Now, itong 2 plus 1.5, that is the moment arm of my uniformly distributed load. So, kung ito yung resultant ng aking uniformly distributed load, yung distance nito hanggang kay point E is half of 3, that is 1.5, plus these 2. So, the value now of my reaction at B is equal to 132 kilonewtons. Summation of forces along the y-axis, that is 0. So, I can solve for the value of my E, that is 48 kilonewtons. Baka may magtanong lang, di ba, kay point B, that is a hinge. kay point E that is a roller. Sabi natin in our previous lessons, pag hinge, dalawang reaction. Yung vertical at saka yung horizontal. Kapag naman roller, yung vertical lang. Bakit kay point B, vertical lang yung kinonsider ko? As you can see here in the diagram, wala na kasing ibang external force along the x-axis. So, magzi-zero out din yung horizontal reaction dito kay point B. Okay? So, nakuha na natin yung mga reactions for the supports. That is 132 kilonewtons and 148 kilonewtons for the hinge and roller support. Pag nakuha na natin yung ating mga reactions, we can now draw the shear and moment diagram using the relationship between the load, the shear, and the moment. Before I continue, na-discuss yun dati during your mechanics of deformable bodies. Kindly type in your answer dun sa may chat box.
Yes, ma'am.
Yes. So, okay lang nga paspasa kanya. So, for this one, since dun kasi sa may first na nabasa natin kanina, the slope of the shear diagram at a point is equal to the intensity. So, if we're going to draw the shear diagram, dito kay point A, meron tayong 60 kilonewtons downward. So, we have to do, pagdating sa shear diagram, for the shear at A, that is equal to negative 60. Then, since walang load from point A to point B, straight line lang yun, then at point B, there is a 132 kilonewtons upward. So, shear at B is equal to negative 60 plus 132, that is 72 kilonewtons. Straight line lang di. Then, from B to C, as you can see there, that is a uniformly distributed load. So, I stopped at 72 kilonewtons since downwards, yung direction ni 40 kilonewton per meter. So, you have to subtract that one. 40 minus 72 minus 40 times 3, that is negative 48. Then, since dito sa may load diagram, kapag straight line, that is a straight line, that is a 0-degree curve. So, pagdating dun sa may shear diagram, from 0 degree, magiging 1 degree curve. Ang itsura ng ating 1 degree curve is a slanting line. Then, from C to D, walang load ulit. So, diretso lang siya hanggang kay E. Now, baka lang kasi may magtanong ulit, bakit diretso lang kay point D? Meron namang moment dun na 120 kilonewtons. Now, we are pertaining to shear. When we say shear, yung mga forces na that will let the beam split. Okay? So, yung 120 kilonewton meter, that is a moment that will cause the beam to bend. So, hindi siya kasali sa may shear diagram. Then again, we stop at negative 48 kilonewtons. Then at point E, mayroon tayong reaction ulit na 48 kilonewtons pataas. So, magzi-zero out yung ating shear diagram. Now, as you can see here, I started at 0. I should end at 0. Kapag hindi kayo nag-end sa 0, there is something wrong in your computation. So, after na nakuha ko na yung aking shear diagram, I can now go to the moment diagram. That is, ang sabi dun, the change in shear between points A and B is equal to the area under the distributed load diagram between points A and B. So, what do that mean? Now, if you can see here, dito sa my shear diagram, from this point hanggang dito sa point na to, that is a rectangle. So, para ma-drawing ko yung moment diagram, I have to take the area of this rectangle, which is equal to 60 times 1. Since nasa negative 60 yun, so that is negative 60. But, as you can see here in the figure in your screen, nag-zero ako sa point na to. since we're dealing with areas, I can only draw my moment diagram kapag alam ko yung areas ng mga shapes na nandito sa my shear diagram. This is my shear. Madali na lang na makuha ko yung area nito kasi this is a rectangle. This is a triangle, but I need to know the value of my x para makuha ko yung area nitong triangle na to. Paano ko makukuha ngayon yung value ni x? Now, using your ratio and proportion. Using your ratio and proportion, I can determine the value of my x. Since itong line na to, from 72 to 48 kilonewtons, that is a line with the same slope, I can use the ratio and proportion. So, 72 over x is equal to 48 over 3 minus x. So, makukuha ko na yung value ng aking x, which is equal to 1.8 meters. So, kapag nakuha ko na yung value ng x, I can now draw my moment diagram. Again, kailangan kong makuha yung value ni x at this point kung saan nag-zero si shear para makadrawing ako ng aking moment diagram. So again, sabi natin kanina, from itong point na to, this is a rectangle. So that the moment from A to B is negative 60 times 1, which is negative 60. Then from B to C prime. Asan dyan si C prime? This is my C prime kung saan nag-zero si shear. That is positive 4.8. Diba, sabi natin, itong line na naka-slant na to, this is already a 1 degree curve. Na pag pumunta na ngayon dito sa may moment diagram, itong 1 degree curve na to magiging 2 degree curve. Ang itsura ng ating 2 degree curve ay para siyang parabola. Now, ang tanong kasi dito, how will we connect negative 60 and positive 4.8? Paano yung magiging itsura ng ating curve? Will that curve upwards or will that curve downwards? Before I share with you kung paano ko kinukuha kung yung aking curve ba ay concave or convex, paano tinuro sa inyo i-connect si negative 60 at si positive 4.8? Paano nyo malalaman kung yung curve natin is concave or convex? How did you encounter problems like this during your deformable bodies? May kausap pa ba ako? Ma'am.
Yes, ma'am.
Oh, kas ano garod nga ma'am? Oh, kas nila tantikasyon ko. Kas ano ko nga i-connect ni negative 60 ka ni 4.8? Jay, kas ano titsura na di curve ko? Convex or concave? Smiley or sad? Anong tinuro sa inyo? Sad. Miss, paano mo nasabing sad? Yung or pababa yung curve ko. Paano mo nasabing ganun? What was your basis on that? Basta sad, taisot imbagada sad. Haan ba mabalin nga the curve? Jay, ayun. The relationship between shear and moment is direct law. Kas ano garot? Ay, adali nagsimbong bat nga may isa. Jay hinge ma'am, paapan jay pin. Okay. So it was discussed to you during your deformable bodies kung paano i-connect si 60, ay negative 60 at saka si 4.8. Tama yung sagot ninyo, sad. Sa mga nakalimutan kung paano nakuha yung direction ng curve that pababa siya, what I'm using is this one. Itong diagram na to. Itong tinatawag naming DD. So, kapag mapapansin nyo dito sa may shear diagram, nasa taas siya. Since nasa taas, that is positive. And nag-start ako from 72 kilonewtons, nag-end ako kay 0. So, 72 to 0, that is decreasing. Again, yung ating triangle ay nasa taas, so that is positive. And the shear is decreasing. So, positive, decreasing. Positive, decreasing. Ang itsura ng aking curve ay ito. So, tama yung sagot nung classmate nyo. Sad, kumbaga kung emoticon, sad or pababa jay curve tayo. Okay? Next. You may use the diagram I'm using, or you may also use yung kung paano tinuro sa inyo how to determine kung pababa pa or pataas yung ating curve. The same lang yung result na makukuha natin. So, moving further, nag-stop ako kay 4.8 at C prime. So, if I'm going to determine now the moment from C prime to C, my answer is negative 24. So, andun siya. Again, paano ko ulit i-connect si 4.8 at saka si negative 24? From itong C prime, dito si C prime, then this is C. So, nag-start ako ng 0, then nag-end ako kay 48. Disregarding the sign, from 0 to 48, that is increasing. But, itong triangle na to ay nasa baba, so that is negative. So, negative increasing, the my curve now looks like this one. So, if I'm going to connect 4.8 and negative 24, it looks like that one. Then, from C to D, that is a straight line. Again, kapag straight line, 0 degree curve yon. So, pagpunta kay moment diagram, magiging 1 degree curve. Ang itsura ng ating 1 degree curve ay slanting. And from C to D, the moment is negative 72. Then, saan ko kinuha si 120? Di ba pag yung load diagram natin kasi kanina, there is a moment of 120 kilonewton meter doon sa point D. Since the direction is clockwise, so that is positive. Negative 72 plus 120 is 48. So we just have to connect that one. Then, yung area from D to E is a rectangle. So, 48 times 48 minus yung area ng rectangle na yon, that is 0. So, again, I started with 0. Dapat mag-e-end ako kay 0. Itong negative 72 na to, since there is a moment at point D, and this is a clockwise moment. Kapag clockwise, positive. Kapag counterclockwise, minus. Okay? So, negative 72 plus 120, that is 48 kilonewton meter. So, ganyan yung pag-drawing using the relationship between the load, shear, and moment diagram. Let's have another example. So, for this beam, mayroon tayong internal hinge at point B. Internal hinge, yung nakikita ninyo na ito. Shucks. Internal hinge na ito eh. So, very first thing you have to do is to determine the external external reactions. But, kapag hindi nyo ginamit yung function ng internal pin, you cannot solve for the external reactions. So, we have to separate yung AB hanggang dun kay B, C, D, E, F. So, nasa sa inyo ulit if, kung ano ang i-consider din yung side, left, or right. So, in my case, I'm going to consider the right side of my beam para makakuha ako ng values. So, since point B is an internal pin, meron ulit tayong internal reaction that is VB. And if I'm going to take the summation of moments at point A, I can solve for the value of my VB. The summation of forces along the Y, I can solve for my RAY. Then, again, bakit 0 si RAX? Walang horizontal forces. Even if you go back to the original beam diagram, wala kayong makikitang forces along the x-axis. Kaya magzi-zero out rin lang yung horizontal reactions dito kay may A at saka kay F. So the value of VB is 40 and RAY is 20. RAX is 0. After na nakuha ko na dito sa my right side, I'm going to consider now the left side of my beam, that is beam BCDEF. So mapapansin ninyo dito, VB is upwards. Kapag lumipat na siya, si VB the same magnitude but opposite direction. That is to maintain equilibrium. Then take summation of moments at point C. My RF is equal to 35 kilonewtons. Again, paki-double check na gid values nga makikita yo dita screen nyo. Baka ada na miss out ko. Summation of forces along the y-axis, I can solve for the value of my RC, which is equal to 110 kilonewtons upwards. Paki-double check, tama ba? Baka ada mo na na-miss ko. So, nasolve ko na ngayon yung mga reactions at point A, point C, and point F. After na nakuha na natin yung external reactions, we can now draw the shear and moment diagram. So, I'll draw first the shear diagram. Ma'am, nagpaspas. Ay, sige. Sorry. Sublihan tayo dahil garon. Paki-double check man usto negative values ko. Nagpaspas ka no. Subliyak na lang dahil ko. This is the right side of the beam AB. And itong B na to, that is the internal hinge or internal pin. And as you can see there, I can solve the value of my VB and RAY, RAX. Baka may magtanong kasi ulit, bakit nawala yung moment dito? Di ba dapat may moment dyan at saka may horizontal chuchu? Di ba nag-zero out garud dito niya? Tikat na sa uwan, ag-zero out not lang di horizontal reaction dito eh. Inikat ko di moment dito eh. Kasi ag-zero mot lang may di moment. You can double check that one. If I take moment at here, tapos si RAY ko is 20, makikita ninyo na yung moment at B is equal to 0. Kaya yung kinonsider ko na lang dito is the VP. Lahat ba ng mga beam or lahat ba ng mga internal hinges kapag hiniwalay ko mag-zero out? No. hindi lahat ng mga moments dun sa may internal hinge or internal pin ay zero. Depende yon sa external loadings. But for this case kasi, mag-zero the moment can be because of the uh, external forces. Okay? So, pag nakuha ko na yung internal reaction at point B, I can now go to the other side of the beam, which is B, C, D, E, F. As I've said a while ago, itong VB na to, upward siya. Pagdating doon sa may B, C, D, E, F, the same magnitude, that is 40 kilonewtons, but opposite direction. That is to maintain equilibrium. Okay? So, taking moments at point C, I can solve for the value of RF and summation of forces along the Y. I can take RC. Okay na? So, that is how you're going to determine the external reactions. Now, hindi pa tayo tapos dito kasi I need to draw the shear and moment diagram of this beam. Since nakuha ko na yung mga values ng external reactions, I can draw my unahin natin si shear diagram. At point A, meron tayong 20 kilonewtons pataas. So, ang gagawin ko lang dito is mag-drawing ako ng line that since pataas si 20, positive siya. So, yung ating 20 kilonewtons nasa taas nung ating line na ito, yung kulay black. Then, we have this itong 24 kilonewton meter na to. Since downwards siya, so negative, ang gagawin natin dito para makuha natin yung value dito sa my point B, that is 20 minus the area of this triangle. What is the value of that? 20 minus the area of this triangle. Mano ti value you? Paki-kabel man ni J chat box. 20 minus the area of that triangle from A to B. 60. 40 mo. Double check. 20 minus G kwa. 20 minus area of this one. The area of that triangle is 1/2 of 24 times 5. 60. Minus D, di ba? That is... Okay. So, tama yung nilagay kong 40 kilonewtons. Positive G20 kasi ada iso na dyan nga to. Positive da ito eh. Since downwards kasi yung direction ni triangle, so minus. The area of this triangle is tama ka, 60. So, 20 minus 60 is negative 40. Okay? Since dito ayan ti load diagram triangle ito. Since triangle yan, that is a 1 degree curve. Di ba? Sabi natin in the previous slides, kapag naka-slant yung line, that is a 1 degree curve. So, dito sa may load diagram, 1 degree curve yun. So, pagdating kay shear diagram, yung 1 degree curve, magiging 2 degree curve. So, dito sa may shear diagram, 2 degree curve na siya. So, ano yung magiging itsura ng curve ko? Upwards ba or downwards? So, again, it's your choice kung susundan ninyong yung discussion nyo during your previous year subjects. But as for me, mas convenient para kanyak di diagram nga didi. So, pakasta di shape ko. Kasano nga nagbalin nga kasta. Hangko nga nag-include di diagram. Kasi 'di ba doon sa may diagram, let me go back doon sa may to. Positive D and negative I. Negative D and positive I. So, I'm going to use itong diagram na to para malaman ko kung paano yung aking curve. Downwards ba or upwards. So, I ended here. How will I connect positive 20 and negative 40? Now, dito sa may load diagram, nag-start ako, itong triangle na to, nag-start ako from 0, then I ended at 24. So, since na, yung direction kasi is downwards yung aking load. So, negative. That is negative increasing. Since negative increasing, and from my diagram, yung shape ng aking curve is downwards. So, tama yung isang kaklase nyo. Downwards siya. So, ganito yung magiging itsura ng aking curve. Then, from B to C, walang load. Since walang load, diretso lang yung aking diagram. Then, may pataas na 110. So, negative 40 plus 110. That is 70. Then, from C to D, wala ulit load. Diretso lang siya. 70 minus 45. What's... Gosh. That is 25. So, i-connect ko lang DI. Then, wala ulit load from D to E. 25 minus 60 is negative 35. Then, at F, may pataas na 35. So, magzi-zero out siya. So, again, I started at 0. I should end at 0. Okay tayo dito sa my shear diagram before I go to the moment diagram. Okay. Siguro. So if I'm going back now to this illustration, before I can draw my moment diagram, kung mapapansin ninyo dito kay may point G, nag-zero ulit si shear diagram. Then, nag-zero out dito ulit. Nag-zero ulit dito. So, I need those distances. Walang problema sa point na to kasi alam ko na kung ano yung distance nito from B, that is 3 meters. Then, itong point na to hanggang dito sa point na to, that is 4 meters. So, walang problema doon. Ito na lang yung problema ko, itong point G. What is that distance? So, paano ko makukuha yung distance X? How will I get that one? Now, again, using ratio and proportion. Gaya yung ginawa natin kanina. I preferred using yung triangle dito sa my load diagram kasi mas familiar ako sa triangle. I'm not that familiar with curved ones. So, mas prefer ko dito sa may triangle na to, using ratio and proportion, the value of my y is equal to 4.8x. Then, from that, dun sa may shear diagram, at point G, the shear is equal to 0. So, if I'm going to formulate now an equation wherein the shear at G is equal to 0, and kapag titignan ko dito sa may load diagram, yung value ng G na to is itong area na may Y. And how do I get that value? That is 20, itong 20 na to. Ima-minus ko ngayon yung area ng triangle na to. Yan yung VG. Nakuha natin, VG is 0. So, para makuha ko yung Y, kasi kapag alam ko na si Y, makukuha ko na si X. So, to determine the value of Y, I need the area of the load diagram. So, how do I get that one? That is 1/2 of X times 4.8X. Paano ko nakuha ito? Di ba itong 20 na to is this one? So, I have to deduct the area of the load diagram. Yung area ng aking load diagram ay itong triangle na to, itong kulay yellow. And the base of that is X. The height of that is Y. At nakuha naman natin kanina, yung aking Y ay 4.8x. So, it's just a matter of substitution. I can get now the value of my X, which is equal to 2.89 meters.
Ma'am, nakamute ka.
Ay! Hamot! Nagpatinggaan na dyan ang nagyuan. Ay, so X is equal to 2.89 meters. Okay? Mangagdak?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Next, wala pa tayo sa moment diagram. So, kapag nakuha ko na ngayon si value ng X, I can now draw my moment diagram. So, my X is 2.89. Diba, sabi natin kanina, para ma-drawing ko si moment diagram, I need the areas. Looking at this diagram, alam ko na ngayon yung area nito kasi this is a rectangle. Pati yung area nito. Okay lang yan. Pati ito. Nakukuha ko na. Pati itong area na to. Alam ko na rin to kasi rectangle to. Walang problema. But, itong point na to ang hindi ko alam. Paano makukuha yung area? This is point A. This is point B. This is point C. Paano ko makukuha yung area ni A to B? This is not a triangle. Take note, this is a 2-degree curve. Kaya hindi yan triangle. Hindi mo pwedeng gamitin yung 1/2 base times height. Since that is a 2-degree curve, and if I'm going to explode itong ABC, ganito yung magiging itsura. Yan. So, yung X natin is 2.89, then from G to C, that is 2.11. Now, dito na papasok yung sinasabi nating spandrel. You've encountered spandrel during your geometry, and the area of a spandrel is equal to BH over N plus 1. Where in your B, that is the base of the spandrel, and H is the height of the spandrel. N, that is the degree of curvature. Now, for this problem, yung ating degree of curvature ay 2. So, the value of Rn is 2. Pero, dito kasi sa problem na to, ang area naman na kinukuha natin ay hindi yung kulay gray. Hindi yan yung area na gusto kong kunin. Ang gusto kong kunin na area ay yan. Yung area 1 at saka yung area 2. Yan yung mga areas na kailangan ko para makuha ko yung, or para ma-drawing ko yung aking moment diagram. So, how will I get area 1 and area 2? Using spandrel. Let me just erase this one. Have you encountered spandrel during your deformable bodies? Sabay ba katungtong ko? May kausap pa ba ako?
Yes, ma'am.
Na-encounter niyo this spandrel? Or nalipatan niyo?
Awan, ma'am.
Awan. Ay!
Awan, ma'am.
Ay, so in here karon, ang concern ko dito is the area 1 and area 2. And area 1 is not a spandrel. It is, kumbaga, yung other side ni area 1, yun yung part ng spandrel, pero hindi siya yung spandrel. And so, paano ko makukuha ba si area 1? So, for area 1, that is equal to 20 times 2.89. Kasano ka naala dito 20 times 2.89 nga data. Sige, subliak lang ulit dito. Diba, kunan tayo tatay, if I'm going to isolate itong part na to, ito yung magiging itsura. And yung kulay green ay gray na yan yung tinatawag nating spandrel. Yung kulay gray, hindi yan yung main concern ko. Ang main concern ko ay yan. Yan yung mga areas na kailangan ko para ma-drawing ko si moment diagram. So, paano ko makukuha si area 1? Now, this is my equation for area 1. Kasano data? Kasano nga naala data? Diba ni area 1 data niya? If I'm going to draw a rectangle here, ay nga rectangle, dito is area di rectangle nga data kat 20 times 2.89. Tama ba ako? The area of this rectangle, 20 times 2.89.
Yes, ma'am.
Okay. Then, since the area 1 lang gamit ti concern ko, kat dito kulay white nga dito, that is a spandrel. Dito kulay white. So, para makuha ko si area 1, from this rectangle, I have to subtract yung area nitong spandrel na to. And the area of a spandrel is given as BH over N plus 1, wherein the base of my spandrel is 2.89 and the height is 20 over, ano tong 3 na to? That is N plus 1. Again, this is a 2-degree curve. So, 2 plus 1, that is 3. The area now for my A1 is 38.5. So, nakuha ko na ngayon si area 1. Next, apana ka ni area 2? Ni area 2 is kulay green. So, how do I solve that one? Yan. That is equal to 5. Nangalngala akay manan dayto eh. Baka damagan yung manan, nangalngala akay dayto eh. Diba, dun sa first na diagram kanina, yung kulay gray, itong buong to. Ito yung kulay gray kanina. Tama. So, yung kulay gray kanina, yung area niya is base that is 5 and the height is 60. Kasi ano nga nagbalin nga 60 di ay? 40 plus 20, that is 60. And divide it by n plus 1, that is 3. Again, itong nasa loob ng bracket, that is the area of the bigger spandrel, yung kulay gray kanina na nakita ninyo dun sa may diagram. Then, I have to substitute the Yung 5 times 60 over 3, yan yung area nitong malaking spandrel na to. And to get the value of my A2, kailangan kong isubtract yung area nung maliit na spandrel na to and the area of this rectangle. Kaya yung 2.89 times 20 over 3, that is the area of this smaller spandrel. Itong 20 times 2.11, that is the area of this rectangle. Then, yung remaining na area, that is now the area 2, that which is 38.5. Kinawatan tayo, no, kasanok na naala ni area 1 ka ni area 2. Or makapaulaw pa lang, sublian yun to na lang, dahil yung discuss ko kanya yun. So, ganyan ko nakuha yung values ni A1 at saka ni A2. Again, kailangan kong makuha yung value ni A1 at saka ni A2 para makadrawing ako ng aking moment diagram. So, since nakuha ko na si area 1 at saka si area 2, again, the value, ito yung ating area, ito ay yung ating area 1, ito ang ating area 2. And area 1 is equal to 38.5, area 2 is equal to 38.5. So, pwede na ako mag-drawing ng aking diagram. Take note ulit pala, si X dito is 2.89, And so, if I'm going to draw now, from A to G, ang na-compute ko kanina is 38.5. Bakit ko siya nilagay sa taas? Kasi yung dito sa my shear diagram, nandito sa taas itong A1. So, since nasa taas, that is positive. So, from 0 to 38.5. Now, again, what would be the shape of my curve? Will that be upwards or downwards? So, again, if I'm going to use this diagram, since nasa taas siya, positive, then I started from 0, I started with 20, I ended at 0, so that is decreasing. So, positive, decreasing. Positive, decreasing, the shape of my curve is downwards. So, kasta titsura na. Then, from point G to point B, that is area 2. And area 2 is equal to 38.5, yung nakuha natin kanina. Since nasa baba siya, so minus. So, 38.5 minus the area 2, that is 0. Paano yung magiging itsura nung curve ko from G to B? Again, that nasa baba siya, so negative. Then from 0 to 40, that is increasing. So, negative increasing, ang itsura ng aking curve ay downwards ulit. Ayan. Then, I ended at 0. The area of this rectangle is 40 times 3, 120. Since nasa baba, so 120. Connect ko lang DI. Again, dito sa may shear diagram, that is a 0 degree curve. Pagdating kay moment, 1 degree curve. Then I ended at 120. Yung area from point C to point D ay this one. So, paano ko makukuha yung area nito? Again, that is a rectangle. Nag-end ako kay 120. So, 120 plus, kasi nasa taas, negative 120 plus 70 times 2. That is 20. Positive 20. So, if I'm going to connect them, slanting. Right? Then, from D to E, nag-end ako kay 20. 20 plus the area of this rectangle. 20 plus the area of this rectangle, that is 25 times 2, that is 70. So again, dito sa may shear diagram, from D to E, that is a 0-degree curve. So pagdating kay moment diagram, magiging 1-degree curve na siya. Then, nag-end ako kay 70 minus the area of this rectangle sa baba, that is 0. I just connect that one, and my moment diagram looks like this. Okay? Before I go to the next example, any question? Dito sa problem na to, any question dito? Or
Ma'am, paulit man, check pa.
Jai?
Kay last month, presenting.
Jai?
7 kilonewton yung moment.
Pakitype, Chappy. Pakitype na lang, Chappy. Jai, 70 kilonewton. Ah, okay. Hey. So, ay, so dito di ba nag-end na ka ni 0? Nag-end ako kay 0. Then, the area, itong rectangle na to is 40 times 3, 120. Since nasa baba siya, so minus 120. Again, itong rectangle dito sa my shear diagram, that is a 0-degree curve. Pagdating kay moment, that is a 1-degree curve. 1-degree curve is slanting DJ. Then, nag-end ako kay 120. Nag-end na ka ni 120. Then, from C to D, DJ area, DJ shear diagram, isa dito To take now the area of this, that is equal to 70 times 2. So, nag-end ako kay 120 minus, plus. Kasi adadji nga to iso na. So, plus 70 times 2. Yeah, 70 times 2. That is negative 120 plus 140, which is equal to 20. Since dito sa my shear diagram, this is a 0-degree curve, so pag i-connect ko si negative 120 tsaka si 20, magiging 1-degree curve. Nag-end na ako kay positive 20. Now, I have to consider the area from D to E, which is this rectangle. So, paano ko makukuha yan? Nag-end ako kay 20. Positive yon kasi nasa taas. Since nasa taas din ito, so plus. Then, itong rectangle na to, the area of this rectangle is 25 times 2. So, 20 plus 25 times 2 is 70. Tama? Then, since dito sa may shear diagram from D to E, that is a 0-degree curve. Pagdating kay moment, that will become a 1-degree curve. So, I'm going to connect 20 and 70 with the slanting line. Then, from E to F, again, that is a rectangle, 0-degree curve. So, mapan di moment diagram, magbalin nga 1-degree curve, mag 0 di. Okay? Okay tayo doon? Okay po. So, let's move to the next example. Now, this example is a cantilever beam. When we say cantilever, sa isang end, restrained siya, then free end siya sa kabila. Dahil pagod na ako sa kasasalita, charot. Kindly give me the values of the reactions at point A. Again, free end dito So, ang support lang natin ay nakay point A. No? Point A lang ayan, i-support tayo. So, can you give me the values for the reactions at A? Obviously, wala tayong reaction along the x-axis, 0 di. So, reaction tayo lang dito is the vertical and the moment. Okay lang at overtime tayo? Baka umabot ang 11:30 or 12. Ibali, once a week lang ba't nga Google Meet? Okay lang niya hanggang alas 12? Okay. Once a week lang. Ano saan yun? Can you give me the values for the reactions at A? Paki-type na lang. So, RA is equal to MA is equal to. Anya, G80. RA, uno MA. Bakit may question mark? Huwag masyadong matagal MA daw yung 80. How about the other values? Oh, nagpayag. Ang charot. Ay, so, 80. How about the others? What are your answers? Nga negative di jay. G-ink di ay. Dalo saklatan. Stop. Idaduma kay apay may sa estudyante. Uy, reactions lang. Para mabilis tayo. These are the answers. Moment at A is 20 kilonewtons, that is clockwise. Then, vertical reaction at A is 10. Bakit 20? Bakit 10? So, if I'm going to take summation of moments at point A, itong uniformly distributed load na to, the area of that is 5 times 2. The moment arm, 1/2 of 2, that is 1, plus 2 plus 1, that is 4. Tama. Since downwards siya, and kapag nag-moment yung aking resultant dito kay my point E, that is clockwise, so positive. Then, meron tayong counterclockwise na 60 kilonewton per meter. So, since that is counterclockwise, so minus 60. The moment now at point A is equal to 5 times 2 times 4 minus 60. 20 kilonewton meter.
Negative.
Now, that is clockwise. Okay? Then, meron tayong 10.
Ma'am, tama na yun.
Nga negative 20. Take note ang ginagamit ko kasi dito, kapag clockwise, positive. Kapag counterclockwise, negative. And it turned out, dito sa ating tawag dito, equation, positive si 20, kaya clockwise siya. Okay, so those are the values of my reactions. Now, I can now draw the shear diagram. Wait. 5 times 2 times 4 minus 60. DJ Mr. Who? Sige, wait lang. Nalipat ang mat ni M.A. Okay. So, for this diagram, di ba ni A, at that TJ moment, this is MA, right? Then, at that ni RA. Then, no ag-moment nak kan ni point A, ag-moment nak dito nga point, that clockwise dito nga uniformly distributed load. So, that is 5 times 2. The moment arm is, 4. Then, since this is counterclockwise, so minus 60. Now, do not forget, there is a moment here. Iso ni MA. Since that is clockwise, in-assume ko, so plus MA. That is equal to 0. This is 80. Tama? Minus 60. Okay. Ako yung mali. MA. Plus Tama pala. Sorry, ako yung mali. Tama yung kakasa nyo. So, the vertical reaction is 10, but ngayon, ngayon, double check ko yung answer ko. Paki-double check man. Daytoy. This should be counterclockwise. Paki-double check counterclockwise di ay. Okay po. So if I'm going to draw the shear diagram, 20 J Balasi. Pa-double check nakman before mo ituloy dito eh. Gusto ba? Dinaalak gamin tatay is 20 kilonewton meter clockwise. 120 kilonewtons. 20 kilonewton meter G value G moment kani A. But is that counterclockwise or clockwise? Paki-double check man dyan, answer ko. So clockwise. Okay. Clockwise J iso din na clockwise. Okay, clockwise. Shucks na wala ako J. Okay. So if I'm going to draw na the shear diagram, it will look like this. So positive G10, from A to B walang load, so diretso lang din. A, B to C walang load. Then C to D, meron tayong 5 kilonewton per meter. So nag-end ako kay 10 minus the area of that uniformly distributed load, that is 0. Okay? For the moment diagram, since at point A meron tayong 20 kilonewtons and that is clockwise, na kapag sinabing clockwise, nasa taas siya, so positive 20 kilonewton meter. Then, the area dun sa may shear diagram, itong area na to, that is 10 times 1, so nag-end ako kay 20. 20 plus the area of this is 30. So, i-connect ko lang siya. Then, meron akong 60 kilonewton meter at point B that is counterclockwise. So, pababa. 30 minus 60 is negative 30. Kukonect ko lang ulit yun. Then, from B to C, meron ulit area dito na rectangle. This one. So, how do I get the area of that one? That is 10 times 2. So, negative 30 plus 10 times 2, that is equal to negative 10. Then, I'll just connect that again. Then, so obviously, magzi-zero ako dito. Pero, since dito sa may shear diagram, this is a 1 degree curve. So, pagdating kay moment, magiging 2 degree curve. So, ano magiging itsura ng curve ko? Again, I'm going to use this diagram. So, dito kay may shear diagram, nasa taas siya, so positive. Then, nag-start ako kay 10, then 0, so positive decreasing. Positive decreasing, ang itsura ng magiging curve ko is downwards. So, ganyan yung magiging curve ko. Yan ngayon yung itsura ng aking shear and moment diagram for this cantilever beam. Sensya na sa confusion. Another problem. Another illustration. I think this is the last for beams. Nasa beams pa lang tayo. And so for this beam, again at point D, that is an internal hinge. Then, meron tayong different loadings. So, ang unang gagawin natin is to determine the external loads. If you merely look at it, then i-apply natin yung static equations, wala tayong makukuha na values. So, we have to use the internal hinge. So, I'm going to analyze first the left side of my beam, ABCD. Take note of the loadings dito kay may ABCD. Kay point D, mayroon akong internal reactions. Meron akong reaction kay BV. Now, kay point C, kung mapapansin ninyo kay point C, meron ako dito yung itong 10 kilonewtons na to, nakaslant siya. So, since nakaslant, meron akong vertical and horizontal component ng 10 kilonewtons. So, paano ko makukuha yung vertical component ng reaction, ay ng load kay point C? That is 10 times sine 60 degrees. That is equal to 8.66. Paano ko ulit nakuha itong 8.66 na to? But if I'm going to draw here the vertical component for this 10 kilonewtons. Ito yung 10 kilonewtons. Ito yung vertical component. Diba this is 60? Yung vertical component nitong 10 kilonewtons ay opposite nung 60 degrees. Apay ka, opposite ka damot dito nga side ni. Diba, no ialis ko mo dito, isumot lang mo data J vertical component na. So nga, 10 times sine 60. Sublihan nyo na lang di ko, di trigonometry yun. Kasano ka na ala dito nga 10 sine 60 degrees. Then, no maalak di CH or the horizontal component of that 10 kilonewtons, that is equal to 10 times cosine 60 degrees, which is equal to 5 kilonewtons. Then, so, kapag nakuha ko na yung vertical and horizontal component nitong 10 kilonewtons, I can determine now the values for BV and the internal reactions. So, if I take summation of forces along the x-axis, my DH is equal to 5 kilonewtons. Again, saan galing yung 5 kilonewtons? Kasi po, diba, dito sa may point C, andun si 10 kilonewtons na nakaslant. So, I need to get the vertical and horizontal component of that. The horizontal component of this 10 kilonewtons is equal to 5 kilonewtons. Yan ngayon yung ika-counteract ni DH. Summation of moments at point D. I can solve for the value of my BV, which is equal to 7.705 kilonewtons. Then, from that, masosolve ko na rin si DV, which is equal to 3.205 kilonewtons. Itong BV na to, nag-moment ako kay point D. So, itong CV, no ag-moment ka ni point D, isojay 8.66, the moment arm of this is 1. Right? Then this triangle here, no ag moment daytoy nga triangle kani point D counterclockwise, iso nga negative. The area of this triangle is 1/2, the base is 3, and the height is 1.5. The moment arm for this triangle is, kung andito yung resultant, di ba ti centroid iti triangle is andito sa part na to. Diyan mag-a-act yung resultant. And that distance is equal to 1/3 of the base. Managip yun dito yung geometry yo. Baka man na nadagdamag gamin na nangalaak dagita nga values. So, again, if this is the resultant, yung distance nitong resultant is 1/3 of the base. Yan. So, 1/3 iti base. 1/3 iti base, my base is 3, and you have to add these values. Kaya yung aking moment arm ay ito. Okay? So, dun ko nakuha si value ni BV, which is equal to 7.705 kilonewtons. Then, nakuha ko na rin si DV. I can now proceed to the other side of my beam. So, yan yung mga values na nakuha ko kanina. Dito na tayo sa may right side. Kanina, DH is 5 kilonewtons. Again, the same magnitude, opposite in direction. The same with DV. Then, makukuha ko na ngayon yung mga reactions. Can I change this one? This should be EV. Para hindi tayo malito. EV, dapat yun. Then, there is a moment. Can I change again that one? That should be moment at A. So, those are the external reactions at point E. Nilagay ko na si EH kasi ang horizontal reaction lang naman is the 5 kilonewtons. So, EH is equal to 5. If I take summation of moments at point E, makukuha ko si MD, which is equal to 30.82. Pa-double check man no usto dagiti yung kabkabel ko, baka manin no nagkamali ako. Then, summation of forces along the y-axis, my dV is equal and double check the values kung tama tong mga pinaglalagay ko. Before I draw my shear and moment diagram. Okay? So, these are now the values of my reactions. those are the values. So I can draw now my shear diagram. From A to B. Again, that is a 1 degree curve. So pagdating kay shear diagram, magiging 2 degree curve na siya. That is positive kasi nasa taas since that is negative kasi pababa yung loadings natin. And from 0 to 1.5, so that is increasing, negative increasing. It will look like that one. Then from nag-end ako kay 2.5, merong pataas na 7.705. So plus 7.705, 5.455. Then from B hanggang dito sa point na to, walang load. Kaya diretso lang siya. Then at point C, di ba mayroon tayong vertical component ni 10 kilonewtons downwards. So you have to take that one. My answer is negative 3.205. Connect that one. Wala ulit loadings doon. Then from point C hanggang sa may point na to, that is a rectangle. So nag-end ako kay 3.05. Again, nasa baba, so minus ito. Negative 3.205 minus the area of this rectangle. That is equal to negative 5.205. So, i-connect ko lang ulit siya. Then, mapapansin ninyo ulit, meron akong concentrated load dito na 5 kilonewtons. So, negative 5.205 minus 5, that is negative 10.205. I-connect ko lang ulit siya. Then, from this point hanggang kay point D, again, that is a rectangle. Nag-end ako kay negative 10.205 minus the area of this rectangle. That is equal to negative 12.205. So, i-connect ko lang ulit siya. Then, may pataas na 12.205. Magsi-zero siya. So, ganyan yung aking shear diagram for this beam. Now, I can draw the moment diagram for this one. The area, again, dito sa may A to B. Again, this is a spandrel. Baka lang manan kami nadagdamag. Kasanok nga maamuan ng spandrel. Ito ay nati part is spandrel. Diba, dito yung triangle. The height the triangle is on this side. Then, dito yung 0 na. So, na dito yung height na. Dito yung spandrel dito ikat iso dito. So, no baliktadang mat dahil no matkaste di triangle mo. So, no di spandrel dito No di curve mo kung mga ikat pakaste niya. Basta di curve mo. Di spandrel dito. Aan nga dito Dito di spandrel. Nagkinawatan tayo Jay. Mangagdak ba? Okay. Nagkapsutin yung boses ko. So, let's continue with this. So, for the area of my spandrel, again, area of spandrel is BH over N plus 1. The base of my spandrel is 3. The height is negative 2.25. The N, or the degree of curvature, is 2. So, if you're going to substitute those values in your calculator, the area of my spandrel is equal to 2.25. So, ano magiging magiging direction ng aking curve? Downwards or upwards? Again, I'm going to use my diagram. So, since dito sa my shear diagram, nasa baba siya. So, negative. Then, from 0 to 2.25, that is increasing. Negative increasing, my curve now will look like this one. So, if I'm going to draw, it looks like that. Then, nag-end ako kay negative 2.25. Then, I have to take the area of this rectangle. Again, nasa taas siya, so plus 2.25 plus the area of this rectangle, that is equal to 3.25. So, i-connect ko lang siya. Then, nag-end ako kay 3.205 minus the area nito. That is equal to 0. Then, from this point, from C hanggang dito, this is a 2-degree curve. Paano ko nakuha si 8.41? Diba nag-end ako kay 0? 0. Then, itong trapezoid na to, that is, nasa baba siya. So, minus. The area of this trapezoid is, the area of the trapezoid, that is base 1 plus base 2. Divide it by 2 multiplied by height. So, my base 1 is this one, 3.205 plus my base 2 is 5.205. The height, ito yung magiging height ko, si 2. Doon ko nakuha si 8.41. Pa-double check na usto na ginibagi sa inkawil ko. Then, lastly, 3.85 nag-0 di ay. Paki-double check man dagiti nga values kung tama. Jay niya di eh. Ay, ada nag-question dito eh. Ada nag-question, haan ba nga negative decreasing? Sige, subiyak na lang ulit. Okay. Sige. Ito yung subiyak na lang dito. Ay, di ba nag-end na ka ni 0J niya? Ting apart. So, 0. Then, i-minus ko dito nga area. Kasi ito na di baba. So, minus, this is a trapezoid. So, di area jay, trapezoid. Area ti trapezoid. Katinaalak nga answer ijay 8.41. At kasandok nga i-connect dito eh. Di ba nag-start up dito eh? Obviously, this is negative kasi nasa baba siya. Disregarding now the signs of this 10.205 and 5.205, disregard the signs. Di ba dito nag-start 3.205, napanak ijay 5.205. So, nag-increase iso na obviously nag-increase. Negative increasing. Disregard the sign. The same with this one. Diba, nag-start ak ti 0. Then, nag-end nak ije 2.25. Again, disregard the sign. So, 0 0 hanggang 2.25, that is increasing. Again, disregard the sign. So, since nasa baba, negative increasing, so nga ti-shape di jay curve ko downwards. Okay po.